How did it go with question 3? The first 3. It was okay. The second 3 a bit more tricky. Okay. Alright, the first one I have put on the answers, but let's just go through it again. So you all will remember, we don't work with something if it's not in standard form, ne? We always need to get it to standard form. When it's in standard form, then I can use information from it. So we said yesterday that these two lines are perpendicular to each other, so I steal this one's gradient, which was -1/2, and I use it on AC, and therefore swapped around with a negative, it becomes +2. Okay. 3.2, you had to find the equation, so I put the 2 in the place of the gradient, and then I substitute my coordinate, and I can calculate C to be -1, and my equation is therefore 2x minus 1. Then at 3.3, they said if the equation of AC is equal to y equal to 2x minus 1, and the moment that I saw that, I knew I was right with this one as well. No? They want us to find the point T, and we also spoke about this yesterday. Can you all see that T is the point of intersection between BTD and ATC? So we can just let those two equations be equal to each other. I multiplied everything with 2 to get rid of the denominator. And then I got x to be equal to 4. Substituted into this, either one of the two equations, and then I got y to be equal to 7. Therefore, T is 4 and 7. Remember when they say, when you read the word coordinate, it must be in a coordinate. Next, they said if ABCD is a kite with AB equal to BC, determine the coordinates of C. So what I said to you guys is when we need two variables, we need to find the answer of two unknowns. We can only use the midpoint. Now, yesterday I saw, I can't remember in which class it was, there were people who, you now know that this is the point 4 and 7. Then what they do is they say -2 plus 4 divide by 2 to get an answer. Now the answer you'd get if you do that is the point in between A and T. So remember the answer to the midpoint will be the point that's in between the 2 points. So therefore you should say -2 plus x divide by 2 equal to 4. And -5 plus y divide by 2 equal to 7. Do you all understand that? So don't just substitute without thinking about what you're doing. So I just said that because it's a kite, I know AT is equal to TC. So be sure to add that information because it wasn't given. They just said it's a kite. They didn't say that they are equal to. It's your knowledge that tells you that those lines are equal to each other. So I said AT is equal to TC because it's a kite, and therefore T is the midpoint. You can either say that with the reason kite or that with the reason kite. You don't have to say both things. They mean the same thing. Okay, I substitute, and then I calculate it, and I find x to be 10 and y to be 19. Okay. Now, I said that I would teach you a shortcut when it comes to the midpoint. Now let me show you. And you can just use the shortcut without any calculation. You're just going to have to say that T is the midpoint because it's a kite, and then you can write the coordinate. Now look at this. It is fine and it is safe and it is allowed to assume the following. So this point, the x, was -2. How much did it increase to become the midpoint? From -2 to 4. 6. It's 6 more, no? So then you just add 6 to 4, so that one's going to be 10. What did we get? 10. Okay. The other one, -5 to 7. How much more is it? 12. No? Negative 5 to 7 is 12. And 7 plus 12? That's what we got. Okay. So remember the cheat with the midpoint. You can add it up. Okay. Are you done? You got that? Right, that's why that one only counted 2 marks. That you see. Okay. But most of the time, it counts 4 marks. And then you can just give the answer and you're done. Okay, 3.4.2, calculate the length of BT. So I just want to quickly explain our plan once again. BT I couldn't calculate because I didn't have B's coordinate. Right, I couldn't find it because it's not the midpoint of anything. But I could calculate the length of AT because I had both coordinates. And once I have the length of AT, I am just going to say AT squared plus BT squared will be equal to 15 squared using Pythagoras because of the 90 degree in the triangle. You all understand the plan? Okay. So AT I found to be 6 root 5. Then I said AB equal to BT squared plus AT squared. Put your reason, Pythagoras. Substitute, and then you find BT to be 3 root 5. Did you get that? Do you all understand? Okay, I told you that you can leave 3.4.3 out. Now I just want to show you how to do it, but you wouldn't be able to do it now, because we haven't done circle geometry. So when we're going to do circle geometry, we're going to learn a couple of theorems, which we can use, like the alternate angles of a parallel line and the co-interior and the corresponding. We're going to learn those type of rules for a circle. Now, one of the rules is the circle that they are referring to is a circle that touches B and T and C. So it's a circle that looks something like that. Yeah, they say you can draw a round circle, you're crazy, ne? One's pretty round. Anyways, so that angle is 90 degrees. Right. Now we are going to learn in Euclidean geometry that if there is a triangle in a circle and the angle makes a 90 degree angle, then that line must be the diameter, meaning that it goes through the midpoint. If it wasn't 90 degrees, that's not the diameter. But the moment that it's 90 degrees, that is the diameter. In other words, they're asking for the length of the radius. So because that one is 15, I know that one is 15. They told me that as well. So therefore the radius is half of the diameter. So it's going to be 7.5. So you can write the answer there. Just add it to it. AB is equal to BC is equal to 15. That's the radius is 7.5. Just so you have it for study purposes later on. Okay, the first one, calculate the gradient of QS. Remember, we spoke about this one yesterday, and this is something about analytical that you must always look out for, ne? And that is the fact that it goes through the origin. The moment that you have a line through the origin, you must remember, you must somewhere draw it in with a highlighter the moment that you see it. That's the point 0 and 0. So if I want to calculate the gradient of QS, they are misleading you to call it QS. Because now you're looking for S, and you can't find the coordinates of S. So what you had to see was that it goes through the origin, and therefore you can calculate the gradient. because QOS, it's the same line. Do you understand that? Nod to let me know you are alive. Okay? So I say y minus y divided by x minus x, and then I get the gradient of 2. Then they wanted you to calculate the size of theta. So theta is there, it's the angle between the x-axis and that line QOS. To find the inclination angle, I do it using tan theta equal to the gradient. I just found the gradient to be 2. So I'm going to say tan theta equal to 2. And then I press shift tan 2. And I get the answer of 63,43 degrees. Did you get that? Do you understand it? Do you see inclination is very easy? No problems there. Okay, now the fun and games started at 3.3. Let's look at this. They wanted you to find or to calculate the gradient of PS, round it off to the nearest number, but you have P's coordinate, but you don't have S's coordinate. Right. Now let me tell you something. The fact that they said round off to the nearest number should give you the idea that you're going to calculate the gradient with an inclination angle. Because a normal gradient is a rational number. No? So you don't round off a gradient ever. Do you agree with that? Okay, do you see how it's hiding? The clue is hiding. So that just tells us that we're going to have to try to find that angle. Because when we have that angle, we can use the inclination angle to find the gradient. We can use it both sides. Do you understand the plan? Okay, so what I have thus far is I calculated this one. It was what? 63,43 degrees. Okay, I'm going to turn the page a little bit like this. Maybe you didn't see it yesterday when you were doing it at home. Maybe you can see it now. How can I find the size or the size of alpha? No, not the fun. The fun function will give me that angle. Okay? So it won't give me that one directly, but it's a step closer maybe. There. Okay, so you, like what Pelu said now, the 20,23, okay? And then what is it? What? I thought you did it. 180 minus 63.43 minus 20.23. It gives me 96,34, okay? And then? So you're saying like that one, co-interior. Corresponding. Remember, corresponding is under the arms. Okay, so it's close, co-interior. So I would take that one minus 180, I'd get 83,66 because of co-interior. Good job. Do you all see that what she did? She used the alternate to get that one. Then she used the interior angles to get that one. Then she used co-interior to get that one. Okay. I can show you another way. If you have that angle, 63,43, you have that one. because of vertically opposite angles. If you have that one, these two added will give you that one. It's the exterior angle of a triangle. Okay. Is it new mathematics? But it's hiding. Okay. So we have to practice, 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 practice. Alright, you can prefer however you want to find it. I'm going to give you 2 seconds, okay, 2 minutes, to quickly find the size of alpha, 83,66. That's what we're going to get to. In whichever way you want to. So whether you take a longer route, maybe you'd find that angle and then that one and then angles on a straight line, adjacent angles on a straight line, however you want to find it. Quickly find the answer, get to the answer of 83,66. Are you all done? Okay. So I use that one that I told you about. I said that angle TOS, that one right there, is equal to 63,43 with vertically opposite angles. And then I said if I add those two, I get 83,66 because it's the exterior angle of a triangle. Then remember what we're actually busy with is we're trying to find the gradient of PS. So now I have alpha, so I can say the tan of 83,66 will give me the gradient of PS, and therefore the gradient of PS will be equal to 9. Do you all understand? Okay. Next up, we had to find the equation of PS. So I put 9 into the place of gradient, and I substituted P's coordinate, because I had P's coordinate, into the place of X and into the place of Y, and then I found C to be 21. And it's a big number, that it feels a bit weird, but if you look at that straight line, you can see it's got a big gradient. It's going to go up high before it cuts the y-axis. So the 21 makes sense. So PS is 9x plus 21. You don't have to call it PS, you can just call it y, it's fine. Any questions? Alright, then they said if QS is equal to y equal to 2x, determine the coordinates of S. Can you all see I now have the equation of PS? They've given me the equation of QS. What is S? What is S? It's the point of intersection. So I can just let the two equations be equal to each other. Then I say 2x equal to 9x plus 21. Get it alone, solve for x, substitute into 2x, and then I find y as well. Did you have the right equation of PS?
I didn't write the final equation, but then I did get C to be positive 21.
You can just come and show me, okay?
When we're done.
When we're done, yeah. Okay, can I page? The last one, easy, because I now have S. It's -3 and -6, and I have to calculate the length of QS in the simplest surd form. So QS is equal to the square root and it's going to be 3 minus -3, and it is 6 minus -6. And then QS is equal to the square root of 3 plus 3 is 6, squared is 36, and 6 plus 6 is 12, squared is plus 144. That gives me the square root of 180, and that in its simplest surd form, you can type it on your calculator as well, but it's going to be 6 root 5. And there you have it. Then they said at 3.7, did you see there was another one on 3.7 eh? If it is further given that PQRS is a parallelogram, determine the coordinates of R. Okay, so they're telling me PQRS is a parallelogram. I have to find the coordinates of R. Who has a plan for me? Finding the coordinates of R.
And then giving about the colors S1, S2.
What?
Giving out the equivalence. We see when it says, we say S1 and S2.
S1 and S2.
Yes.
Where do you want to put S1 and S2?
I agree with you. And do I consider the line into the parallelogram? What
Oh,
is
are you
that?
wondering about the parallelogram?
Yes.
It's P, Q, R, S. So that line is a diagonal. Is that what you're asking?
Yes.
Okay. Can you see that we have two unknowns? Can you see that? Can I calculate two unknowns with distance? Gradient. Midpoint. Yes. So if we were to do it algebraically, we'd have to calculate the midpoint. Once we have the midpoint, we can calculate R. Or we can cheat. Because this thing is a parallelogram, it is drawn or it is made up in ratio. So in other words, what I mean is, this -2, with what did it increase to become 3? So this -3, if it is increased with 5, what will it be? 2. This y value is 3. It increased to 6. What do you think -6 will increase to? 3 became how many more to become 6? Plus 3. So -6 plus 3? -3. Is it difficult? No, it's an easy cheat, no? But we can only do it when it's a parallelogram or any of the specialized quadrilaterals. Do you want me to show you the algebraic way as well? Okay, I will. It's 3.7. So I'd start by calculating the midpoint of SQ. It's going to be 3 plus -3 divided by 2, and then also 6 plus -6 divided by 2, and therefore my midpoint is going to be equal to 0 and 0. That means the midpoint is at the origin. There's a difference between 0 divided by 2 and 2 divided by 0, ne? 0 divided by 2 is 0, but 2 divided by 0 is not allowed. That's a mathematical error. Okay, so now I have the answer of this midpoint. The midpoint of SQ is the same as the midpoint of PR, sorry. And now I know that -2 plus x divided by 2 must be equal to 0. And 3 plus y divided by 2 must be equal to 0. So I multiply with 2, it cancels out, and then x is equal to 2. I multiply with 2, it cancels out, and then y is equal to -3. And that was exactly what I got when I cheated as well. Do the cheat if you can, because you are saving yourself time that you're going to need at Euclidean. Okay. Wherever you can save time, save the time. Okay, 3.8. They said A is 5 and 4, B is 0 and -1, and then C is T and 2. Now we haven't had the collinear question in one of the other questions, so I want us to specifically look at this one. They are telling you that these points are collinear. They want you to find the value of t. Can you see it's only one variable? So it's fine, we can use the gradient formula because we know collinear points are about gradients. So I'm going to calculate the gradient of AB. That means I have the answer of the gradient of my choice, BC or AC, whichever one I choose. And then I can just inverse to get to the value of t. So first I start with the gradient of AB. It's 4 minus negative 1 divided by 5 minus 0. That gives me 5 over 5 and my answer is 1. So the gradient of AC is going to be 4 minus 2 over 5 minus t is equal to 1. My unknown is in the denominator, can you see that? So I can just swap it. So the 1 goes there, so it's actually just 4 minus 2 equal to 5 minus t. What's 4 minus 2? 2. I'm going to take the 2 over, it's going to become minus 2, and I'm going to take the t left so that it becomes positive. So it's positive t equal to 3. And that's it. Okay, I want you to do question 5 for me for tomorrow. Only question 5, but I'm going to go through it with you again. So the first question, it's the second one, the second pack of papers. I gave you 2 packs of old question papers. Oh, quickly come look in here. Oh wait, let me see if we're going to have to go through all of it. Then we're going to find it. Alright, so the first question is, they want you to find the gradient, to calculate the gradient of line AC. Any problems with that? No, I've got both coordinates. I have the gradient formula, so I can calculate it. Next up, the equation of the line DE. There's DE. I have a problem. Can you see that? Because to find the gradient, or to find the equation of a straight line, I need 2 coordinates. And I only have 1. But now I have to go and look and see, maybe I can steal it somewhere. Can I steal it? Why can I steal it? Because of those 2 things. No. Parallel lines, their gradients are equal. If it was perpendicular, it's reciprocal with a negative. Sharp. Alright. And then you have to find the size, calculate the size of angle A. Now they've made it a bit confusing. Alright. Let's think about this. That angle right there is not an inclination angle. I don't have another angle so that I can work with the exterior angle of a triangle or whatever. Can you see this is actually a quadrilateral even with the x-axis. It's not a triangle. So if I were to find that angle, it's not helping me at this stage. But the gradient that I have should lead you, guide you to what you're going to calculate. So I have the gradient of AC and therefore the gradient of DE, both of them. So I can calculate this angle, or I can calculate that angle. It's going to be the same size. Now, is there a way that I can get this angle to that angle? Do these two have something in common? What? It's corresponding, but not as it is there. No. It's corresponding if I draw a line there. Right? Do you agree with me? So that means I can have this, the size of this angle. This one and this one is the same. What's that size? What's the bottom part? 90 degrees. Can you see that? That's almost a straight line that I'm going to have to draw to get the corresponding angle there. And that one is 90. So in other words, I'm just going to get my inclination angle. I know it's the same there, and add it to 90, then I've got that angle. You see, everyone? So you're going to do it yourself. Next up, and this one is confusing, the next question. So I need you to listen carefully. They say B. Can you see there's no B? Can you see it? Okay. B is a point in the first quadrant. Here, somewhere. Such that A, B, D, E, in that order, forms a rectangle. So, A, B where I don't know where it is, D, and E forms a rectangle. So where do you think B is going to be? Somewhere here. Maybe there. Somewhere there. Okay, B is somewhere there. Now look at what they're doing now. Now they ask you to calculate the coordinates of M, the midpoint of BE. So BE, there's BE. Can I calculate the midpoint of BE with B and E? No, because I don't have B and I don't have E. I can't even find B or E. But what do you know about a rectangle? A rectangle's diagonals. They bisect each other, which means AD's midpoint is the same as BE's midpoint. Can I calculate the midpoint of AD? Yes, easy peasy. And then they ask you for the length of the diagonal BE. Can I calculate the distance if I don't have either coordinates? What does it say about the diagonals of a rectangle? They are equal. They are equal. So if I can calculate the length of AD, I know that BE is the same length. But you're going to have to give those reasons. Ne? You're going to have to calculate the midpoint of AD and then say, right, the midpoint of BE is the same because it's a rectangle. And then you're going to calculate the length of AD and then say, right, but BE is the same length. And then your reason will be, it's a rectangle. Do you all understand? So they're asking the question there, but you're working here. But it's the same. So only this question 5 for tomorrow. There's about 5 minutes left. You can start quickly, do 3.1 as far as you can, and then you guys can finish it at home.